So hello everyone and welcome back to another video, and this is about an HD7770 that's actually not technically mine. So this is another HD7770. If you remember, we once had one of these already on the channel, and that particular one kind of just died. Like, it literally just stopped working, and I don't know why. So I still don't know what was going on with that one, but after it died it had like problems turning on all the VRMs. It was turning on the VRMs at first and still didn't work, so that's not the issue. It's just like that card was very, very weird. This one is the other card. So at first, I've said it in the first video about my other HD7770, me and my friend both wanted to get HD7770s because these are pretty cheap and they have a lot of things that you can do to them. Like, this is an AMD card, and AMD cards are generally more complex than Nvidia's, which might not be true anymore. Like the RTX 3080, like that PCB is a total mess, and it's like the most complex and weird PCB I've ever seen. But at the time, this was actually, it does have a lot of different voltage rails, let's say it like that. And yeah, so me and my friend wanted to get one of these each, and since they're 7770s, like, they are cheap and they are mostly based off the same PCB. Like, this is pretty much the same thing that I had. It's slightly different. Like, I had a Sapphire one, which as far as I could tell was literally like the same PCB with zero alterations. This Gigabyte card, that's the heatsink. This is actually slightly different. There's slight layout changes, and they changed the MOSFETs, which like this comes with, it comes with 4935N low sides. This one is using some Vishay MOSFETs that I can't get datasheets for. Like, I can get datasheets for the high sides, but not the low sides. So yeah, I can't really tell how the VRM performs, but like, it's in 7770. We don't really care. So yeah, so how I got this into my hands is just like my one 7770 died. I actually replaced that one. I have another Sapphire 7770 that I just never did anything with because both the memory and the core suck. This one has really good memory and the core is kinda average. So yeah, how I got this is I visited my friend a while ago, and he basically told me, like, he, let's just say he is not really that into modding as I am. So he told me, like, look, okay, I can take the card and just do whatever I want with it. So I said, okay, I'm gonna take it and I'm gonna mod it for you, which is, well, what I've done now. So I've tried to do a slightly different approach on this, which is why all the volt mods, which literally every voltage rail on this has a volt mod, so that's why it looks so messy. Yeah, these are attached by long wires and not like I usually do with short wires and then kinda glued to the PCB. This is kind of an, yeah, like, technically this should be better if you have the card installed and you want to change the voltage with one of those potentiometers, because then you can just take it in your hand and adjust it, whereas otherwise with my usual way of doing it, you'd have to kind of weirdly get very close to the card and kind of try to access that thing, and that can be really annoying if you want to do it while the card is running and installed. So this should be easier to adjust while the card is running. I can't really test it because this 7770 also doesn't work in my test bench. I can't say, like, it's not really dead. It just, my test bench can't see it. Like, the PC doesn't pick up that the card is installed. It just throws like no GPU detected error. Like, all the VRMs on this are working, and like there's nothing really suspicious about the card. Like there's nothing really telling me that something's wrong. So the only thing I can say about it is my test bench doesn't like it. And like my test bench has something with 7770s, like remember the first one died, this is not getting detected. And the other one that I have that I replaced the first one with has, that one runs, but it has some weird issues where it just crashes and like is really unstable even if you don't overclock, and like it's just a huge mess. My test bench and 7770s don't really get along. So yeah. And yeah, so what I did on this card, I just wanted to mod everything. So you have a mod for vCore, that's this one. You have vmem, you have PEX-Rail, you have VDDCI. And that's pretty much all the voltage rails on this card. And then I've also put some capacitors, 4 for the memory, 1 for vCore. This one is either also memory or VDDCI. Like the cap, this is solder to, is not vCore, but I actually haven't checked if it's VDDCI or vmem. And yeah, so one reason for all the volt mods is, well, the memory on this, it's GDDR5, and GDDR5 comes with 1.6 volts stock. And well, I actually don't know. This is LPDA memory. I have never checked how LPDA does with voltage. But if you wanna, if you want to adjust voltage on the memory, you can do with this volt mod right here. So yeah, like going up to 1.7 volts. I wouldn't go up to 1.8 because like this is a single phase, which I'm going to get to. Gigabyte did some smart deceiving here. But yeah, this is a single phase. I wouldn't really put 1.8 volts through a single phase because the peak-to-peak voltage is gonna be really bad for a single phase. So your peaks might be at like 2 volts, and running 2 volts into your memory is a really, really bad idea. So I wouldn't go higher than 1.7 volts, but like that's still 100 millivolts extra, and at least on Samsung memory, the 100 millivolts actually do that helps. Then the PEX-Rail, that's pretty much just, well, I'm modding everything else. I also gotta mod this. Really, the only reason why I would want to touch the PEX-Rail is if you take this card on sub-ambient cooling, like dry ice, liquid nitrogen, maybe a really powerful water chiller, but I don't think so. At some point you're gonna run into issues like cold boot bugs or just general cold bugs, where the card suddenly thinks it's at like 2000 degrees because the temperature sensor is rolling over, and instead of very low, it's now displaying very high. And by modding the PEX-Rail, you can most of the time get around that. I don't think this card will run sub-ambient like ever, but the mod is there. Like, I'm modding everything else, I might as well just mod this. So core voltage, well, more core volts, more clocks. That's kind of true for everything except the modern NVIDIA cards. These don't really... we don't know about Ampere yet, but Pascal and Turing, there's basically no scaling on ambient. Pascal apparently scales at sub-ambient a lot. I don't know about Turing, but on ambient there's like... nah. Maxwell doesn't really scale on ambient. At least on the 980 Ti, I've heard some conflicting information that just Maxwell in general doesn't scale on ambient, or that only DGM200 on the 980 Ti doesn't scale on ambient. So I can't say definitively. I only have a working 980 Ti. I have two 970s that don't really work. One of them boots up but doesn't really work, so I can't really say. Yeah, so you have your core voltage here, and then this is VDDCI. So the thing about HD7770s is this core right here, the Cape Verde core, I think. Yeah, it's gotta be the Cape Verde. So this core has a unique thing to it, which when you raise core voltage, the memory becomes less stable. Because for whatever reason, if you raise core voltage, the memory or the memory controller get unhappy on this specific core, like HD7770s and 7750s also use this core. If you raise the core voltage on them, the memory controller, which I guess the memory controller gets upset, and your memory overclock will lose stability. And the way to get around that is you take your VDDCI, which is the power for your memory controller, which is like, this is unique to AMD. AMD cards have a VDDCI rail. On NVIDIA, the memory controller is also powered by the VMEM rail, as far as I know, I think. I have actually never verified that. It's just, I heard it and I'm just taking it for, well, I'm just believing them. But yeah, on this card, if you raise the core voltage, you also have to raise your VDDCI to not get negative results for your memory. Thing is, VDDCI, like memory controllers, are really, really, really easy to get destroyed. So this is running, I think, 950 millivolts out of the box. I would say like 1.1 volts is a hard limit, maybe even 1.05. Because again, this is a single phase. The only not single phase VRAM on this is the 3-phase vCore. So yeah, and yeah, so let's get a bit into the specifics of this PCB, because this is the most custom 7770 that I've seen so far. Because the layout, not like the layout slightly changed, but the components changed a lot. Like all the other 7770s that I've seen use the same MOSFETs and same voltage controllers. For some reason, Gigabyte chose to change both MOSFETs and voltage controllers for this. So this is using these Vishay MOSFETs, which I don't know if you're gonna be able to see which ones they are. Oh yeah, you can see it. Like, these are the MOSFETs. Then over here, yeah. So these are the MOSFETs, and then more interestingly, the voltage controllers on this are all some UP controller. I actually don't know which one this was. It doesn't really matter because there's no datasheet for any of the controllers on this card. How did I volt mod them then? Well, I just went, okay, like this is a pretty cheap card. They're not gonna like change a lot about how the PCB is built. So I literally just soldered the volt mod for vCore. I literally just soldered it to where I would do it on a normal 7770, and that worked. So the controller is different, but at least for the feedback circuit, the way it's wired up is the same. So I wired it up where I would have put the volt mod on a normal 7770, because I saw like, okay, that region looks the same. That array of resistors and capacitors looks exactly like the feedback circuit on the other 7770 I had, which was using the standard controller. So I soldered the volt mod to the same place, and it ended up working. For the other ones, that was even easier, because all the other ones have the very, you can kind of see it here, like I've put plastic dip over them. This is the standard, very, very basic 8-pin IC package. And the thing about them is the feedback pin is always pin 6. And they also don't really have a lot of circuitry around them, so you can see like, yeah, this is going to a voltage divider, that's gotta be the feedback circuit, so yeah. Again, it's some UPI thing. The normal card has some RT thing, but yeah, I actually don't know for a fact if it's the same for every one of these, but every time I've seen this package, pin 6 was the feedback pin. So yeah, that's how I got the volt mod working on the other ones. And yeah, I think now we can get into what smart, kinda deceiving Gigabyte did here. So if you look at the memory VRAM right here, you see that there are 2 inductors. And the first thought I had when looking at the PCB was like, okay, this right here is 6-pin input. this has gotta be a two-phase memory. It's not. Like what I thought is, okay, this is nice, this is two-phase. These are probably dual NFETs. I only noticed that it's not a two-phase when I noticed, oh, these are different ones. These are not the same. These can't be dual NFETs, and yeah, they aren't. What's actually happening here is it's also not the thing that they're just using two inductors for one phase, like ASRock does that sometimes, and I think Asus has done it. This is your VMEM inductor. This is actually 12 volts input filtering for the PCIe slot. Like, instead of putting it here where there's actually a footprint for it, they've put the 12 volts input filtering right over here. Because I guess they're only powering the memory of the PCIe slot and everything else of the 6-pin, so it doesn't really matter where you put the input filtering, like the power's gonna go there anyways. So they just put the 12 volts input filtering inductor right next to the output to, I don't know if it was intentional. I kind of have a hard time believing it, like it has to be. Yeah, I have a hard time believing it wasn't intentional. So yeah, this looks like a two-phase memory, but it's not. It's a one-phase. And I was also really surprised when I measured the output voltage. Like I was troubleshooting when I still wasn't sure like why it wasn't working in my test bench. I was looking at like, okay, is the output missing? And I probed this one and saw 12 volts, and I was like, oh, memory's gotta be dead now. But like overcurrent protection wasn't tripping, and the power supply I have in my test bench is like it trips overcurrent protection really fast. So I was like, why is 12 volts shorted to VMEM output, and why is the OCP not tripping? And then I noticed, oh, there's a resistance of 0 ohms from this to the PCI Express slot. So this is input filtering. Yeah. So kinda funny how Gigabyte put that there. And then also another weird thing is like there's like empty footprints for even more inductors. Like this is where I would usually put the 12 volt input for PCI Express slot. This is where I think the other cards have the 12 volt input for the 6-pin. And then over here, I think they just kinda put the footprint for, well, the 6-pin and then maybe an alternative position for the PCI Express slot power. I don't know. I actually haven't measured because, well, I actually don't really care. So yeah, that's kind of the thing, the interesting part about this card. And I mean, let's talk a bit about the mods. So when I said I wanted to mod everything on this, I wasn't just referring to volt mods. I really wanted to try like every mod on this. So I wanted even more caps. Like this cap is on vCore, and I actually this cap right here I also added. This position was empty, and I put that cap there like because, well, there's an empty spot for it. You can kind of see how I soldered the legs right here. I actually also doesn't know if this is vCore or VDDCI. I suspect it's, well, actually, like this has gotta be VDDCI because otherwise there's literally no output filtering for VDDCI. So this might be also VDDCI, or it might be vCore. I don't know, I haven't checked. I think I should check that. But yeah, anyway, I wanted more capacitors for vCore, and I could put some there. But the big problem is, I like soldering to multi-layer ceramic capacitors. No problem. Like these are on there. These are it's really easy to get these capacitors soldered onto multi-layer ceramics. The big problem is soldering like anything to like inductor and through-hole capacitor legs. I just can't get things soldered to these things. I can use flux, I can use a whole lot of heat. I even tried hot air once. That's how I blew up one of those capacitors, because of course I did. No matter what I try, I just can't get solder to stick to either inductor legs or these capacitor legs. I don't know why. I guess just because the power planes or the components I'm trying to solder to are just like the thermal capacitors is just way too high, and I need like a way more powerful soldering iron for this, which I don't have. Like this is 75 watts. This should be enough. But like these might be difficult because they're right next to the inductors, and the inductors and generally just the V-core power plane have a lot of thermal mass. I might need a more powerful soldering iron for that, and well, I don't have one. This is gotta do. So yeah, I'm kind of debating right now whether I'm gonna fill these last multilayer ceramics with even more capacitors, or if I'm gonna keep this free to put a power bridge here, because like I originally planned to do like a power bridge with not the super thick wires I have. Those are not gonna work. I have some AWG28 wire. AWG28 is really thin, like it's this stuff over here, it's really thin. And the problem with that is it's not gonna move a lot of power, and well, it's not gonna do anything if the connection I create doesn't have a lower resistance than the power plane. Or like a hugely, like it shouldn't have a like 10 times higher resistance than the power plane, then it's not gonna do anything. So I thought, well, these wires are relatively easy to solder. I could just solder like a lot of them, like 4 or 5 of them, and that would be like the equivalent of one thicker wire. Problem again is, well, I've already gone over this, I can't get anything to stick to these things over here, and that's why the power bridge would start. And then it would go to the core right here. And I'm kind of debating right now whether I'm going to attempt a few more, attempts at getting a power bridge here, or whether I'm just gonna fill this up with capacitors and just call it a day. I'm kind of inclined to just put capacitors there, because I've tried this so many times and I've failed every time. But I can do cap mods relatively like nicely by now, and I'm also running low on flux. Like it's gonna be enough for like, if, well, depends on how much I do, but this is like enough for, it might get me through the month. But like it was like here like a few weeks ago. So I've used half of what I had from then. And yeah. So I'm kind of running low on flux, like, I really still have a decent amount of solder, and I barely use my solder wick, so I'm okay there. But I really need more flux. And I'm not gonna get more of this. It helps, but the thing that's really annoying about this is it leaves a sticky brown residue that I try to get it off, you can't get it off. It just, it's sticky, it's brown, and like it's basically impossible to get it off the board. And yeah, so I don't want more of that stuff. I'm gonna look for better flux. Yeah, I don't know what kind of flux. Like, I guess the stuff that Louis Rossmann is using is decent, but I've looked that up and it's actually quite expensive. Which, well, it's quality flux, but maybe I'm gonna find some budget stuff that's not as astonishingly bad as the stuff I have. But yeah. So this is the HD7770. I don't know if it's a CMD edition, considering it's not mine. It's from a friend. Though, like, he hasn't told me he wants it back. It's just like, It doesn't work on my test bench, so it's either that or my test bench just doesn't really doesn't like HD7770s. So either it's dead and it's just like a trophy for a wall, or I can't use it. So yeah. Like once I think I'm finished with this, like I think it's gonna get a few more caps. I might try to put some multilayer ceramics here on these empty pads, but I don't know how that's gonna work out. Like it's really close to these can capacitors here, and if I blow them up, well, yeah, I don't really like doing that again. I've already done it once and it was enough. So yeah, I guess this might get a couple more caps on the back. And then, well, guess I would be finished then. And well, then it's gonna sit somewhere until my friend, until I meet my friend again and can give it to him, or if I maybe find a way to get it working. But as of now, like the card is just it's not being detected in my test bench. Like it runs, every voltage is there. It just doesn't, like, it's not getting detected. So yeah. That would be it for the HD7770. Yeah, again, I don't know if it's a CMD edition. I guess it is. I guess it's a CMD edition. I really wouldn't know what to call it otherwise. So, yeah, hope you all enjoyed watching. And yeah, till we see each other next time. Goodbye.